Okay, we're going to look at some transformations. To transform means to change. So, here we go. Alright, so we're going to look at first what we call vertical translations. A translation is a fancy name for a shift. So if you take a function f of x, and if you either add or subtract a number onto the end, the effect is that you're going to see your graph shift up or down. Okay, so if it's a positive number, you're going to see that your function is going to move up k units. Okay, if you're moving up k units, it really means you're adding whatever that k number is onto the y values. The x values are not going to be changed at all. Okay, only y is affected. Same thing, if our k is negative, this means you're moving down. Okay, so that would mean you're subtracting whatever the k number is to the y values, and your x values remain unchanged. Okay, so think about x squared versus x squared plus 3. Okay, or x squared versus x squared minus 4. Okay, in our first case here, this is going to be shifted up 3. In this case, it'd be shifted down 4. Okay, so that deals with vertical shifts or vertical translations. Okay, now we are looking at horizontal translations. So this is where we are shifting a function either left or right. Okay, so horizontally. So if we're moving a function left or right, that means we're changing x. Whereas when we moved it up or down vertically, we were changing y. Okay, so this is a change to a function that you see happening on the inside as opposed to the outside. And it kind of goes against what you would logically expect. So by that I mean if you see something like x minus k, right? K again is just some number. So that minus actually means that our function would be shifted to the right k units. That means we would be adding k onto the x values, and in doing so, y would be unchanged. Okay. Likewise, down below here, if we see x plus k, so something like x plus 2 on the inside, there you're actually shifting left k units. And if you're moving a function to the left, it actually means you'd be subtracting k to the y values. Alright, and so if you're just strictly shifting to the left or to the right, once again your y value would be unchanged. Okay, so if we're talking about x squared versus, now if we were to see something like x plus 3 quantity squared, and if we were to look at x squared versus x minus 4 quantity squared, you can see that there's a change going on in the inside. Okay, so this plus 3 here would actually indicate that if we started with our x squared graph, we would be moving it 3 to the left. Likewise, if we took x squared and then compared it to this new equation, that minus 4 on the inside would take it and move it 4 units to the right. So it's always the opposite of what you would logically expect to happen. Okay? Alright, so let's talk about translations in general. So we're talking about both vertical and horizontal shifts. Sometimes you're going to see that they are expressed in vector form. So a vector can be expressed in this form. It's called component form. Right? It looks like you have a column here in parentheses with two numbers that we're calling A and B. A represents our horizontal movement. Okay, that's either left or right. And B represents our vertical movement, which is either up or down. Okay, so if you were to see the vector 3, 0, this would indicate that, again, the top one is our horizontal movement, so this would indicate we're going 3 units to the right, and the 0 on the bottom indicates that our vertical movement is nothing. So this first vector would tell us to move 3 units to the right. This next vector of negative 2, 5, well, up top you see the horizontal component is negative 2. that would tell us that we need to go to the left 2 units, and then the 5 in the bottom that represents our vertical shift, that would tell us we need to go up 5. Okay. Likewise with our last one here, 0, -1. The 0 for the horizontal component means we're not moving left or right. The 1 for the vertical would mean we're going down 1. Okay, so sometimes we see our translations or our shifts summarized or expressed in the form of vectors. Just remember the top number is your x movement or your horizontal movement. The bottom number is your vertical or your y movement. Okay, in this last example here, we're going to be dealing with this point 6,8, which is on the function, and we're going to keep coming back to that point 6,8, and we're looking to find the new point after these different transformations. So the first one here, f of x plus 1. So this is a vertical shift up 1. So that means our new point of 6,8 is going to become the point 6, 9. So the x value stays the same, it just gets moved up 1, so we're adding 1 to the y value. Likewise, f of x minus 3, this will be shifted down 3. Alright, so again, x is going to stay the same. We are going down 3, so that means we need to subtract 3 to the y value. So 6, 5 would be our new point. Okay, again, we're going back to 6, 8 each time. Alright, this original point. So f of x plus 2, this would indicate that we're going 2 to the left. So that means I need to subtract 2 to the x value. That would give me 4 for my new x value. And this time y stays the same. My next one, you see that x minus 4 on the inside. That means you'd be shifting 4 units to the right. So I would have to add 4 to the x value. That would give me a new x value of 10. And my y value stays the same. Okay. Again, I keep going back to this 6, 8 each time. Now, the fifth one here, we're actually looking at a couple different translations. We have on the inside this x minus 1, which means we're moving to the right 1, and then this plus 2 on the end means we're going up 2. So, if we go to the right 1, my new x value is 7, and if I go up 2, my new y value is 10. And finally, a translation of, now we see this vector notation again. So the 0 up top means I'm not moving left or right. The 3 in the bottom means I'm going down 3. So I'm going to keep my x value the same. If I'm going down 3, my new y value would be 5. Okay? Now, if you're given an actual graph, okay, of a function as opposed to just one point, what you want to do is pick out some key points and just do the same process that we did here for, maybe 3 or 4 points, and then just connect your new points together to make your new graph. Okay?